Here, this circuit, we saw this circuit before in the initial and final values, where we have the source that is 30 volt. It was 30 volt before t equals 0, and after that it will be 0. Okay, so when t is negative, it is 30. After that, it is 0. So we are interested in t more than 0. Then this volt source will be 0, which means that you turn it off. So you short it, actually. You short it like this. So now, if you look at the circuit, imagine how it looked like. This one is switch is connected. So you have this source connected to inductor, resistor, and the capacitor and the resistor in parallel. So 4 components in parallel, including 2 resistors. The equations that we have are for RLC, not 2R. Okay, but here the 2 resistors are in parallel, so you can combine them. So you can combine this R1 and R2 as if the only one resistor they are in parallel. So R, the total R equal R1 parallel with R1. Since they are actually equal, then it will be just half of the resistor. So if R1 is 100, then R equal 50. If R1 is 50, if R1 is 50, R equal 25. If R1 is 20, R equal 10, and so on. So this is the value that we are using here. This is supposed to be R1, R1, not R. So the value of R that we will use here is the half of this R1 that we have in the table. Okay, so for example, if you want to calculate alpha when R1 equal 100, that is 1 over 2. R is 50 in this case, half of this times C. If you want to calculate this one here, will be 1 over 2 times R, which is 25 times C, and so on. And then we calculate alpha and omega 0 the same way, and decide which case is underdamped, like here, critically damped and overdamped. And this will be the transient solution for the current, I t of t. For the final value, for this one here, this one is just constant here. Okay, and you have the capacitors open circuit, so you have 2 resistors in parallel, and the inductor short circuit. So the inductor short circuit will short this resistor and the other resistor also. So actually you have a short circuit. Then the 4 ampere will go through this inductor. Then the current will be 4 amperes. This is the final current for this circuit. So this is I state will be 4 ampere. For the initial and I of t and I of 0 and di by dt, you have to go back to the solution of this circuit in the initial and final value as the first assignment. So as I said, the steady state value is 4 ampere, and what you need to do is just to substitute in these equations here to decide what is the value for A1 and what's the value for A2 using these equations here. Okay. It's supposed to be plus. Okay. So it's supposed to be like this. Okay. So this is the value for the current. The total current is the high steady state plus the transient response. So all what you have to do is just decide what's the value for A1 and A2 based on these equations here. Based on these equations, this one and this one, or this one and this one, or this one and this one, depending on the case that you have. There's another example. This is a problem in the assignment that's not solved in the handouts you have. So here you have this source connected to R or L, C, R, okay, and you have a 3 ampere. But once you disconnect this switch here, you have the current source. You still have a current source feeding this RLC circuit here in parallel. Okay, so again, what we need to do here is to decide what are the initial values, and this circuit is solved before, so you need to know how can you calculate the initial values for the current and the derivative of the current, and what is the final value? What's the final value for the current? Imagine that you remove this branch, and the capacitor is open circuit, the inductor short circuit, and you have a resistor here. The short will cancel the resistor, then 3 ampere will continue in the short circuit. So it makes sense that the steady state value is 3 ampere. Okay, and you calculate, you have R equal 10, 5 and 2, 10, 5 and 2. L is, what's L here is 5 Henry. C is 1 over 20. C, which is 0.05, 1 over 20. Then you calculate alpha using this equation. You calculate omega 0 and you compare. And if it is under damped, this is the equation. If it is critically, this is the equation. If it is over damped, this is the equation. Then you use the initial conditions to calculate the constants A1 and A2. Here, as you see, ISS equal 3 ampere, as I mentioned before. Okay, so you just use these two equations here to solve for A1 and A2. And these two equations solve for A1 and A2 if it is critically. This one is under damped. This one if it is over damped. So this is, I believe, this is the last slide in this part, which is the second order circuit. So in this chapter, we talk about initial and final values for I of t, I dot of t, v of t, v dot of t, and the final values v infinity and I infinity, where v is the voltage across the capacitor, I is the current in the inductor. We talked also about series and parallel circuit, RLC circuit, source free, without any source. And then we added a source. If we add a source, we call it step response. This was the third part of this chapter here. Okay, so this is the assignment. These problems are already solved. I solved them, but you will find only the solution for these two in the handouts. Okay, so thank you very much for watching, and see you in the next video.